Today at Techarati, we're delving into a critical topic for modern data centers, high density environments and the cooling challenges they present. This interview is part one of an ongoing series of Chatsworth products where we explore the data center industry challenges and innovations. I'm Rebecca Uppendale, tech reporter at Techarati, and today I'm joined by Sam Rodriguez, Senior Product Manager for Cabinets, Containment and Thermal Solutions at Chatsworth Products. So thank you for being here today, Sam. And I'm going to go straight in with the first question, which is, with the growing demand for data centers, efficient thermal management is more critical than ever. Can you explain to us why high-density environments pose unique challenges when it comes to cooling?
Thanks, Rebecca. Well, I guess over the last 10 to 15 years or so, almost all data centers were designed to be strictly air-cooled. And the target at that time was generally in the 30 plus kilowatt range per rack. But most data centers were not anywhere near that, right? When we talked to customers and data center owners, they were well below like 10 kilowatts a rack. Of course, there were exceptions at that time, like high performance computing, but that was pretty much it. Since then, most data centers were pretty much operating at those lower performance levels. The criticality of the high efficiency designs and discipline to manage airflow simply wasn't there. Right. And that all changed recently with the introduction of AI applications and things like ChatGPT and high performance computing. So to support those processes, things like the processors, CPUs and GPUs have really changed to meet the needs of those applications. So instead of managing, previously a 200 watt processor, today we see processors like the NVIDIA H100X SXM that are 700 watts and climbing. Right, so all of a sudden, AI is for the mainstream, and thermal management has become pretty much a critical need.
And so, for you, what are the most pressing thermal management challenges facing the industry right now?
Well, like I mentioned, with the adoption of applications like AI and HPC across all industries, it's obvious that more and more companies are finding new methods to use it. So the issue is that they need to deploy these high power hungry processors into existing data centers, and they can't wait until a new one is built, right? However, in many cases, they need to do this utilizing the existing power and cooling infrastructure, but instead of a 10 kilowatt rack, the load is increased to 50 kilowatts and higher.
In your opinion, what are the biggest risks of not addressing thermal management proactively in high density environments?
Well, the biggest risk, of course, is the equipment and the performance. The higher performing processors are very expensive, and it's critical to ensure that they receive adequate cooling to be able to function at their peak performance. Now, don't get me wrong, there are control measures in place to ensure that the equipment isn't going to be damaged if they're not sufficiently cooled and they get too hot. However, to protect the processors, what happens is that these devices are designed to throttle down, which results in an overall loss of performance. You get a slower response time, and you're wasting energy.
And so what are the common mistakes that we're talking about these risks? What are the common mistakes made by those trying to evolve and adapt to higher heat loads?
Well, we see that there's a failure to implement efficient thermal management techniques in a data center that results in an inefficient system overall. And basically you end up oversupplying cooling to compensate. So the thing to consider is that any device that's designed to be air cooled can be effectively cooled, even in a high density application, as long as you meet the airflow needs. That means that the cabinet design and the data center design have to be robust enough to ensure that the chilled air that is available is provided to a device for cooling. So you have to ensure that isolation between the chilled air supply and the hot exhaust air are completely isolated. So when you look at a cabinet design, it must include airflow isolation techniques, things like air dams. Filter panels must be used in an unused RMU space, and if you're using ceiling grommets or brushes for any cable ingress or egress into the cabinet. Now, when you get outside the enclosure, there are things like vertical exhaust ducts, hot and cold aisle containment. You've got to use those to properly connect and seal the cabinet to the room, right? Lastly, the chilled air supply must provide the overall needs of the equipment, and you must maintain a higher pressure differential than the return, right? So the air-cooled devices have fans that are going to draw the air into the device regardless of where the airflow is coming from, as long as there's adequate supply available. And then the last thing to think about is there's new technology like waterless direct-to-chip liquid cooling, which can be added to the system to remove heat from those super load processors.
And so that actually leads me quite nicely onto my next question, which is within the industry, as you've just said now, we're hearing a lot about liquid cooling. And can you explain why this is tailored to high density environments? I know you've talked a little bit about the inner ecosystem of data center, but can you explain a little bit more about that?
Absolutely. So liquid cooling is extremely well suited for high density applications, right? There are many options available, including full immersion and direct to chip. In full immersion, the entire system is submerged in a liquid. The benefit to that is that all the heat is removed from the devices. The issue is that it's a far departure from current data center designs. On the other hand, direct to chip is another approach where the heat is removed from the high heat components. So the heat's removed from the processors. It can then be managed by the existing infrastructure or moved outside of the space completely. More efficient systems like chilled water and economizers can be used for maximum efficiency.
Aside from the liquid cooling you've just spoken about, are there any other innovative cooling solutions on the horizon that could help optimize efficiency in these high density data centers?
Oh, absolutely. For example, there's a newer system, the ZutaCore HyperCool solution. It utilizes a waterless direct-to-chip solution. So you remove heat from the processors. That heat is then removed by a device called a heat rejection unit, and then the heat transfer liquid is returned to the chip for additional cooling. That waterless system can be used for processors up to 2,800 watts. It's completely waterless, so it's safe. It protects against leaks, and it actually provides a path for 100% heat reuse. It can be used to do other things like heat a building or help to supplement, the hot water needs of a building.
What would you recommend data center operators prioritize when trying to maximize this kind of efficiency we've been talking about?
Well, they need to ensure that the data center is designed for maximum thermal management. Make sure that, like I mentioned before, that your cabinets include all the options to isolate your chilled air supply from the hot exhaust, right? Outside the cabinet, ensure your cabinets are well sealed. Use containment to be able to allow the chilled air that's in the room to reach the equipment, and then balance the cooling needs of the data center to ensure that you've got adequate supply, but don't waste energy by significantly oversupplying or lowering your temperature. And then lastly, utilize newer technology to efficiently cool your high performance processors.
What pitfalls would you recommend companies avoid when scaling up these cooling solutions for high density setups?
Well, I think before you go off and design a brand new data center and spend all the money, to get into these new spaces and then take, that time in your schedule to have to wait until it becomes available, take a look at your data center design. Make sure that you're maximizing the performance. And in a lot of cases, what you find is that data centers didn't properly deploy the containment needs that are required, that were required day one, but they weren't really needed. But now that you do need them, make sure that you're effectively managing and controlling that airflow. If you can do that, a lot of times what you'll find is that you can get a lot more out of existing data centers by actually putting in those practices into place, full containment, filter panels, and do everything that you can to maximize the thermal management of the room. And then if all those needs can't reach it, then of course you're going to be stuck with having to design a new space. But a lot of times you can make use with what you have.
Wow, I think that's really great advice. Thank you so much, Sam, for taking the time out of your day today and for your valuable insights that you've been kind enough to share with us. And as part one of the series of Chatsworth, I hope everyone can stay tuned for part two, which will be shortly coming over the horizon. Thank you so much, Sam.
Thank you very much for having me. Goodbye.